Kia ora. Okay, so I'm just going to really quickly go through how we can calculate things using our balanced equation. So we've just started thinking about the fact that those big numbers that we have when we're balancing an equation actually tell us how many moles of that thing are needed to react with a certain number of moles of the other thing. So we know that we need twice the number of moles for, so if I go back, we've sort of worked out that because we need 1 mole of sodium carbonate, we need 2 moles of hydrochloric acid to react. So if I had 2 moles of sodium carbonate, I would need 4 moles. If I had 3 moles, I'd need 6, etc. Because my ratio is 1 to 2. So that means I need twice as much hydrochloric acid as sodium carbonate in order for everything to react efficiently. So we know that we need twice the number of moles of hydrochloric acid to go ahead. We can use this information to design an experiment. So if I start with 24 grams of sodium carbonate and I want to make this reaction happen efficiently, how much hydrochloric acid am I going to need? So I've got sort of a starting information, but I don't know how much hydrochloric acid I need to add in order for this to be a nice, efficient, no leftovers experiment. So we need to make a list. We need to work out what information that we have and what information do we need. So I've made my list. So I have got my number of moles of sodium carbonate is something I need to work out. I know my mass of sodium carbonate because it's given to me in the question, 24 grams. And I know my molar mass of sodium carbonate because I always have molar mass because I can look it up on my periodic table. I want to work out my number of moles of hydrochloric acid, but I know from my reaction that I need twice as many moles of hydrochloric acid as I have sodium carbonate, so I just have twice as much. My mass is what I eventually want to get to, and I know my molar mass again because I have my periodic table. So step number 1 is that I can calculate the number of moles of sodium carbonate. I have the other 2 parts of that equation, that I need. I've got my mass and my molar mass, so I can work out number of moles of sodium carbonate. So mass, 24 grams, divided by molar mass, 106 grams per mole, gives me, oh no, I'm covering it up with everything. Go away. Go away. There we go. Number of moles is equal to 0.226 moles. So next step, you see I've updated my list with 0.226 moles. My next step is that I can now calculate my number of moles of hydrochloric acid because I know that my number of moles of sodium carbonate is 0.226, and I know that I need twice as much hydrochloric acid because my reaction tells me that I do. So all I need to do now is just multiply my number of moles of sodium carbonate by 2, which will give me 0.452 moles of hydrochloric acid. So now I've updated my list again. I have 2 of the 3 parts needed for my mass calculation, which means that I can now do it. So I have my number of moles, I have my molar mass, and I can work out the mass of hydrochloric acid that is needed. So N equals mass over molar mass, therefore mass equals number of moles times molar mass. So 0.452 moles times 36.5 grams per mole gives us 16.5 grams of hydrochloric acid is needed to react with 24 grams of sodium carbonate.